Okay, guys. So this learning intention of today is this idea of conditional statements. What a conditional statement is it's when we're referring to. So firstly, you know we talked about like the universal set. So if you roll like a dice, for example, the universal set is what? Is there's well the things that can happen is like 1, 2, 3, 4, 5, 6. That's like all the possible outcomes of something that can happen, isn't it? When we talk about a conditional statement, it's referring to the probability of one thing occurring in a particular set, given that something else has already occurred. So given that something else has already occurred, there's like two possible things that can happen. It's the probability of one thing occurring given something else has occurred. So a simple example here is we've got we roll 6-sided dice. And what's the probability that the number we get is even? So what's the probability the number we get is even, given that we already know it's a number less than 4. So that's that keyword there is the word given. So probably it's even, given it's a number less than 4. Now, before we go through any like formal, so we've got a formula here, before we go through any of that stuff, let's just think about that intuitively. If we know it's a number less than 4, what numbers are there that are less than 4?
1, 2, 3.
1, 2, and 3. So what's the probability therefore it's an even number if we know it's less than 4?
1 in 6.
No, we know it's less than...
No, it'll be 1 in 2, wouldn't it?
1 in 3, because there's one even number, which is 2, out of 3 possible numbers, which is 1, 2, and 3, isn't it? So that's what we mean by... so that's different to like, if the question just said what's the probability that the number was even, that would be like 1 in 2, which is 2, 4, or 6 out of 6. So this is a little bit different. That's like a simple example we can work out without needing to use any formulas or anything, but there is a formula we're going to use, and we've got a couple of examples over here where this is a much easier way of working it out. And what I thought we might start with is just looking at this example here, using the formula to see where it comes from. So the formula is the probability of A given B is equal to the probability of A and B both occurring, so the probability of both occurring divided by the probability of just B occurring. So what is the probability of A and B? So that means, what's the probability of a number being even, as well as it being a number less than 4?
1.
What's the probability of that being the case?
1.
So what's the probability, so we have the 6 outcomes. So there's 6 outcomes in total. What's the probability it's going to meet both those conditions? It's going to be a number less than
1 in 6.
1 in 6, isn't it? So it's 1 in 6 over, and what's the probability of it being a number less than?
1 in 3.
Yeah. There's a half, isn't it? So probability of being a number less than 4. So probability of being a number less than 4 is 1 in 2. It's 1, 2, or 3. So it's 1 in 2, isn't it?
Does that add the whole 6?
And so that would be the probability of A and B occurring, which is only one way that can happen, over the probability of just B occurring, which is 1 in 2. And so in total, that gives us, if you do 1/6 divided by 1/2 in your calculator, it gives you 1/3. Which is the same answer as obviously as what we've got intuitively, but that is the way we usually do it. Like we're going to do a couple of examples over here of some harder type questions, because we've already seen how to break these things down like that. So that's, but yeah, we really want to follow this formal way. I mean, it's not, you don't need to. If you get a really easy question like this, you don't obviously need to, but most of the time it's going to be easier to do it that way. Like the two examples I've got on the left on this side of the board. Is there any questions about what we've done so far, what we mean by a conditional statement? Okay, so let's go onto this side of the board, please, Eddie. So this example here, we've got two events. So we roll 16-sided die. 2 events. Event A is that the number is less than 7, and event B is that the number is a multiple of 4. So often with these, this links in, and this is where this is a good exercise to do as well, because it links in a lot of the stuff we've done in probability already. So this one's linking in the idea of a Venn diagram. So the first thing is to write this, or to represent this as a Venn diagram. So a Venn diagram, remember, means we have the four different sections where we have our 2 circles. And what do we could call these A and B. What do we put in the middle of the intersection of those 2 circles? What goes in there? What goes in the middle part? The ones that are in both, isn't it? So let's go through the numbers 1 to 16, and let's just put them in the right spots for a start. So this is if they're in both. Out here is if they're in neither, isn't it? So number 1, where does that go? it goes in set A, it's not in set B. 2, it's just in A. 3, A. 4 would go in the intersection, wouldn't it? 5 would go just in this one. 6 would go just in that one. 7, where would that go? Where would the 7 go?
None.
It'd go in neither, wouldn't it? So 7's not a multiple of, not less than 7 and not a multiple of 4. So 7 would go here. 8 would go here. 9, 10, 11, 12, 13, 14, 15, and 16 would go here, wouldn't it? So we've set that up. That's the Venn diagram we've seen already. Now let's just, as well, because it's sort of good to have it both ways, let's also write down the probabilities of each of these things happening. What is the probability of it being just in A?
5, 16.
It's 5 in 16. Can we all see that? 5 ways it can happen. So there's 5 out of the 16 die that can be just in set A. So they're just.
Isn't it 6 because there's the one that can do both?
Yeah, but we're talking about just. Good question. So we're breaking it down to 4 different things. One where it's just A, one where it's A and B. One. So there's 4 separate parts. So in total, the probability in total of A occurring is 6 out of 16. The probability of only A occurring is 5 out of 16. What's the probability of them both occurring?
16.
1 in 16. What's the probability of just B occurring? 3 on 16. And what's the probability of neither occurring? There's 6 ways, isn't there? Now, again, we can do a pretty easy check here. What's 6 plus 5 plus 1 plus 3? What does that equal up to? 16. So we can make, that's a way of checking we haven't missed anything. So guys, again, like I mentioned with the tree diagrams, which we'll do one over here in a second, there's not really any way of, like, when you get a question like this in a test, please don't try and just skip steps like this. Because if you try to do it quickly, you're gonna end up making mistakes with these probabilities. And it's the same thing. It's the same thing we've seen with a lot of these. Is that once this has been set up, so once you get your tree diagram or your two-way table or your Venn diagram set up, the rest is pretty easy. So this here is saying what's the probability of A occurring? So of us rolling a number that's less than 7, given we already know it's a multiple of 4. So given we know it's the number's a multiple of 4, that's what we know. What's the probability that number is also is a number less than 7?
16.
So, well, that's saying that's the probability of both of them. What we're saying is we know that it's a 4 and 8. So we've restricted down to just the outcomes that are
Right,
these ones here. So we know it has to be 4, 8, 6, 12, or 16. We know it has to be one of those, but we don't know which one. And we're saying what's it? So we can see intuitively that there's four ways we can get a multiple of 4. One of those 4 is what is also fits set A, doesn't it? Now again, if you can't, because this one again is one where it's pretty hard to see that intuitively. That one you can as well, but this one you definitely need to follow the rule. Find the probability of A given B. That's equal to, I might put this in a different colour. So that's equal to, if we follow this rule here, hopefully we can see it's a quarter. If we look back at this rule here, it's the probability, so if you want to go back to this rule.
Yeah, we know. It's the outside is 7 over 16.
No, is it? 7, it's 12, 11, 12, oh yeah, 7.
Yeah.
Sorry, because Robin up here, sorry, 7, yeah. Okay, again, guys, we don't need to be talking, please, while we're going through this. Okay, so if you look back here, the probability...
Wait, why is it 7 on
Oh,
16?
because it's just 7 numbers out here, that's all it was. We just... that was a 9.
What does the A given B mean?
Okay, it means what's the probability... So what this means is saying, if we roll a die, there's a 16-sided die, we know that event B has already occurred. So we know the number is within this set B.
So B is a restriction. A is
Caleb, we know that that B has occurred. We're saying, what is the probability, given we know B has occurred, what's the probability that A has also occurred? So, given B's occurred, what is the probability that A has also occurred?
So it's 1 in 4.
Yeah, so we can see it's 1 in 4 because we know there's only 4 ways that... See, there's only 4 ways that B can occur. It either has to be 4, 8, 12 or 16. And out of those 4 ways, there was only one way that A can occur. And that's
Oh,
up to 4, isn't it?
So if it's find A given B, it's only the B.
Yeah. So the formal way we work this out is we'd say, okay, if you go into this formula, it's the probability of A and B both occurring. What in this case is the probability of both A and B occurring? 1 in 16. Now, what is the probability of, if you look back here, over the probability of just B occurring? What's the probability of B occurring? In total? It's a quarter, isn't it? So it's a 16th over a quarter. And if you put that into your calculator, the 16th over a quarter is equal to 1 in 4.
Because it's just the because when you divide a fraction by a fraction, it's like flipping it all the time.
Yeah.
Wait, where does the quarter come from?
Because if you put it into your calculator, and I won't get you guys to do it now, but if you put it in your calculator, 1/16 divided by 1 quarter.
No, where's the 1 quarter that it divided by?
Oh, because the quarter is the probability of B occurring in total. So it's this plus this.
Yeah,
it's the total probability of B occurring, which is 4 in 16, which is a quarter.
Oh, yeah.
Okay, so that's, guys, so often, I don't want to sort of dissuade you from just trying to use logic, because it is good to look at this and realise, okay, if we can see this and say, okay, let's look at this here. There's one way that A and B both occur. Given B's occurred, there's sort of given B's occurred, there's four things that can happen. The amount of ways out of those 4 that A can also occur is 1, so it's 1 quarter. That's fine to do it like that as well, but you do need to be aware of the formula, and particularly this last one, there's not really any other way of doing it besides using that formula. Part C, it says what's the probability of B, so other way around, B occurring given we know A's occurred. So given A's occurred means we know it's a number less than 6, so less than 7, so 6 or less. So it's one of these 6 numbers here, 1, 2, 3, 4, 5 or 6. What's the probability that B has occurred given we know A has occurred?
One 6.
Well, hey, it's the other way around, so it's 1. We know it's been one of these 6. So it's either numbers 1, 2, 3, 4, 5 or 6. It's the other way around this time. There's 1 out of 6, we can see that, can't we? There's one of those numbers, and there's 6 numbers, only one of those 6 also includes B. So 6 possible outcomes with A, only one of those also is B.